Welcome to Scene 1, Introduction to Quadratics. Notice as the title Introduction to Quadratics gracefully fades in at the top of your screen. This immediately informs us of our main subject, understanding quadratic equations. As the supporting text, a quadratic equation is in the form x2 plus bx plus c equals 0 appears just below. Reflect on this structure. Think of it as the blueprint for any quadratic equation and the foundation upon which we will build our problem-solving skills. Now, turn your attention to the center where our primary equation x27x plus 12 equals 0 is written on screen. Here, the coefficients a equals 1, b equals -7, and c equals 12 uniquely define our problem, ready to be solved using two different approaches. Look further down as the preview text method 1, guessing roots, factoring method 2, discriminant method fades in. This isn't just a decorative label. It tells you that we will tackle this equation by both an intuitive factoring method and a systematic discriminant approach. Each pause induced by the wait calls allows you to absorb this information fully before we delve into solving the equation step by step. The orderly spatial arrangement, title at the top, equation in the center, and the methods preview below ensures that your focus flows naturally from the introductory context to the core problem and then to the upcoming solution strategies. Keep these concepts in mind as you watch. They will form the backbone of our exploration. Now, let's proceed further, building on this clear and structured introduction to understand how both methods ultimately lead to the same solution. Welcome to Scene 2, Guessing the Roots. Notice the quadratic equation written at the top of the screen, x squared minus 7x plus 12 equals 0. Now, let's consider our strategy. We need to find two numbers that multiply to 12 and add to -7. Think about it. What two numbers satisfy these conditions? Here's a hint. Consider two negative numbers. With these numbers in mind, observe as we transform our guess into the complete factorization. X minus 3, x minus 4 equals 0. Then, setting each factor equal to 0 gives x equals 3 and 4. Welcome to Scene 3, Using the Discriminant. In this segment, we'll explore how to solve the quadratic equation x squared minus 7x plus 12 equals 0 by utilizing the discriminant method. Let's begin by looking at the left part of the screen. Here, we have discriminant computation. Notice the general formula, delta equals b squared minus 4ac. Next, we substitute the values to obtain. Delta equals -7 squared minus 4 times 1 times 12, which simplifies to 49 minus 48, and finally, delta equals 1. Now, shifting our focus to the right side, we have quadratic formula substitution. Here, the generic quadratic formula is introduced. X equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Watch as we substitute our values, transforming the expression to x equals -7 plus or minus the square root of 1, divided by 2 times 1. This further simplifies to x equals 7 plus or minus 1 over 2, and finally, we reveal the solutions. X equals 4 and x equals 3. To summarize, the discriminant of 1 confirms that the quadratic equation has two distinct real roots, namely x equals 3 and x equals 4, validating that both solution methods lead to the same result. Welcome to Scene 4, Comparing Methods. In this segment, we will verify that the two different approaches to solving the quadratic equation yield the same result. On the left, we have the factoring method. The equation x27x plus 12 equals 0 factors into x3, x4 equals 0, yielding x equals 3 and x equals 4. On the right, the discriminant method computes delta equals -7, 2, 4, 1, 12 equals 49, 48 equals 1, and by substituting into the quadratic formula, we also obtain x equals 3 and x equals 4. Notice how both methods yield the same solutions, as highlighted here. Both methods yield the same result. To summarize, both the factoring and discriminant methods confirm that the solutions are x equals 3 and x equals 4. Now that we've worked through the solution methods in detail, let's consolidate our understanding with a brief summary. First, recall the factoring approach. Rewriting the equation shows that the roots are 3 and 4. Then, Using the discriminant method leads to the same results. Multiple approaches deepen understanding. Notice how both methods converge to the same result. The roots are unequivocally 3 and 4, as highlighted. In summary, whether through factoring or the discriminant, the quadratic equation confirms the roots as 3 and 4. Embracing multiple approaches enhances problem-solving skills.